Hello there, Chris Soda here, talking to you today about redesigning streetscapes for managing stormwater and increasing tree canopy cover. My details are down the bottom there if you want to get in touch. If you have been to these presentation days before, you would have heard me bang on about street trees and stormwater, and so I'm not going to rake over old ground and talk about things being good for trees and good for people and good for streams and all that sort of thing again. I really want to push today this idea that we can seriously reduce stormwater volumes by sensibly building street tree systems along streets and fundamentally changing how we go about street design and integrating trees with it. A lot of this confidence I have about this comes off the back of work that Jasmine Tom did in her PhD about just figuring out water balances of street tree systems. And when we break the numbers down, trees have got the potential to use a staggering amount of water. And all that's slowing us up so far is how we get the water to the trees, how we hold it in a way that's not going to do any damage to the trees, and so they can access it and grow bigger and better and faster. And if we can do that, then we can actually get a staggering amount of water to return to the atmosphere via trees, just as it did before we started urbanizing. The management problem we face here is that there's just too much stormwater, and there are several projects in the partnership, and there's been focus for several years now about this, reducing the volume of stormwater as being one of the major issues, particularly focusing on new developments. And so the questions we're asking ourselves are very practical ones in terms of how we can do this. How do we get water to the trees at the right place and right time? And more importantly, probably the biggest hurdle is how do you do this without upsetting other things we value? Things like potentially jeopardizing survival of the tree by waterlogging it. And also other practical issues in terms of things like, are we going to mess up existing things like flood conveyance, road stability? Are we all of a sudden going to introduce a major maintenance burden, which is going to sink these things before they even really get off the ground? And this project is all about, I guess, trying to meet all of those issues with sensible answers and to come up with robust designs, develop new standards so that industry can move forward with confidence, build demonstration sites to actually take people out and show them and collect a robust data set. Our overall solution to this, based on the several years we've kind of been looking into various design options and ways to try and meet these challenges, is to go big. If we're going to seriously reduce volumes, then we need big systems. And this is a cross section here, which has been drawn by Jamie Tayton from Aflax for an experiment where we're going to put in out in Cardinia Shire very soon. And it shows the kind of cross section we're talking about, where we have specific inlet pits running separately to the normal stormwater network, which convey flows through large pipes to big storages, which are in nature strip, and then have potentially some capacity to self-clean and slow up water and allow it to actually exfiltrate into nature strips and support trees. There's a lot of maths on here that's more for if you're interested in looking at this later. I guess the big bad thing that's in bold there is that we're looking to make big systems which occupy a significant proportion of their contributing catchment area. What I've drawn here over on the right, this kind of orangey, yellowy kind of color, is showing the concept here. And the concept is that we install a system, an independent system to the stormwater network, which has its own catch pit, and then a slotted pipe which runs effectively the length of the side entry pits and can basically take flows from upstream of one pit, move them through a kind of trench which is made for exfiltration, which can contain structural soil or gravel or whatever, and allow runoff to exfiltrate into the nature strips along this length here. So what I've got here is maybe a 90-meter run, 80-meter run between side entry pits, which captures about 7 properties. And the slotted pipe can run underneath driveways. If it's in a structural soil, then you can build on top of it, and effectively this can bleed the water out into the landscape and trees can access it. The trees are offset from the trench, and so they don't drown, and the trench contains a large enough slotted pipe that it can be accessed for maintenance if required. So this is really what we mean by going big, I guess, is having this big independent system here running the whole length of the street. And when you do this, this changes the ballgame. What does this do for Melbourne Water? We've always had the interesting thing with the street tree research that it's not kind of mainstream Melbourne Water stuff, but obviously it has so much to do with Melbourne Water operations, and so much of the work that folks in the incentive scheme do, Living Rivers, etc. It's about basically capacity building in industry, and Melbourne Water being a hub for distributing the technical know-how of how to do this to not only councils but the consultants that help them do their job. So what we really want to do here is come at a fundamental change, particularly focusing on growth areas at the moment, in order to try and make streetscapes retain significant amounts of runoff for protecting waterways and promoting tree canopy cover and cooling residential streets. As I mentioned, I think so far we've picked up the main thing from all our work so far is that to give industry the confidence to go ahead with these kinds of solutions, the focus needs to be on developing standards and technical guidance. And so that's what we're really focusing on all the projects we've been working on under the umbrella of this work so far. We're not going to shoot for the stars. There are two practical things we want to do with this project: develop those standards and communicate those effectively, and that's it. This project is a funny one. We are effectively working with partners to get funding from agencies like Melbourne Water through things like the incentive scheme, and what we've been doing is going piece by piece, sort of with developing experiments in different local councils, and so it's kind of coming together over time. It's growing relatively quickly, given that we're sort of having to source funding and do things as we go. There are 6 councils we've been working with most recently on these sort of pilot scale experiments, which typically have sort of a few different treatments and are replicated. And so we kind of work with each group and associated consultants or whoever's involved and various stakeholders to develop a design, come up with an experimental design, and then figure out how to instrument it and monitor it. We effectively do the same thing with every single experiment, and that's pretty much run from the design through the construction and into the data acquisition phase. We're starting out west with Melton, and that experiment's been installed recently, and we're itching to get out there and instrument it now that restrictions are easing. And we've also been working a lot with Cardinia Shire lately on a design which we've just about finished. We worked with Maribyrnong City Council on more of an inner city sort of solution as compared to the others which have been growth area solutions so far for new developments. We've also going to start working with Moreland on another inner city design, and also with Port Phillip. We very recently got some interest from Hume to look at growth area development stuff again, and so we're looking to get that up and running very soon. So as you can see, there's a few distributed sort of experiments and partnerships going on for this project. What we've achieved so far is to actually come up with some new conceptual designs. And so for the new developments via the Cardinia experiment, that's very, very close to actually being drawn up as a standard. It's kind of gone through the ringer and been pushed and pulled around. And so we're going to now, I guess, put that through some more experts to get some more reviews on it. But effectively, that's pretty close to something which we can actually roll out for people to build, at least on a pilot scale. And that's when we should see some pretty large uptake and see the demonstration site asset base grow considerably. That design will also work for retrofits. Our conceptual designs for established areas are not so easy. As you can imagine, that's more bespoke. With new developments, it's a relative clean slate, and so it's a bit easier for design standards. Whereas established areas, there's lots of nuances and subtleties in terms of things that are site specific. So we're working on those. Actual experiments in the ground. Melton experiment, as I mentioned, has been constructed, and the Cardinia functional design is done. So we're going to start collecting some data very, very soon on these kinds of ideas. effectively what we're doing with this project is keeping on moving with designing, constructing, monitoring and repeat. And so we're effectively instrumenting for soil moisture status, so we can track where water goes and we can see if the tree is going to respond well or not. And also obviously monitoring runoff, runoff flows, and getting an idea of actually how much we're capturing from these systems relative to what we've modelled that they'll capture. In the new developments, we'll monitor the Melbourne experiment, construct the Cardinia one very soon. That's about to go in the ground. And then we just started working with Hume and potentially Whittlesea up north. And so we'll have a look at some options for getting some studies in up that way. And we'll be doing that in partnership with some developers, which is very exciting for the first time because we'll get another point of view around the table. Our developed area stuff, so the Maribyrnong experiment that we'll set up is about ready to construct in the next 6 months or so, and we're just getting started on those other inner city solutions in Moreland and Port Phillip. Bit of a whirlwind experience with the project. There's a pretty significant project team on this one. The person I'd highlight in terms of who's done the majority of work so far is Vaughan Gray, who you may remember picked up and ran with street tree research while he was still at Moreland City Council, and has thankfully been able to continue that to some extent in his new role in at Melbourne Water. Thanks very much, and please do get in touch if you've got any queries.